Hi everyone, you're welcome to today's Saturday session with ExamRevision. I'm Robert and I'm going to be taking you through some stoichiometry exam questions in this session today. So as I've just said, we're going to do some stoichiometry and we're going to look at some exam questions. So that's what our learning intention is for today. But before we begin, I want to look at a brief summary of some of the aspects of stoichiometry. We're not going to look at all of them today. I'm just picking out the ones that are relevant to the exam questions that we're doing, but let's have a look. So it's important to know some of the calculation types that can come up in stoichiometry. And what I will say is stoichiometry is scattered all over the paper. No matter what question you're doing, you're going to be using the skills of stoichiometry. However, in particular, questions that are assessed involve looking at empirical formula and molecular formula, the percentage composition by mass, or using balanced equations to find the mass, the mole, or the volume of reactants and products. And that is the most common part that will come up. Manipulating balanced equations, using your knowledge and applying your knowledge that you already have from conversions of mass to moles to volume, etc., to try and figure out values in relation to reactants and products. So as a result, it is incredibly important that when completing stoichiometry calculation questions, that you have an understanding of your mole conversions. So you must know how to convert from moles to grams and back, moles to number of litres or number of centimetres cubed and back, and moles to number of particles and back. One of the other types of calculations that can come up is theoretical and percentage yield, but this won't be covered in this video, but it can be found on the ExamRevision website. So let's take a little look at a revision of our mole conversions. So here is a little chart that I've created to summarize our mole conversions, and as you can see here, the center is moles. So that means no matter where you start and no matter where you want to go, you're always going to have to go through moles. So for example, if you're starting with litres or number of centimetres cubed, you will have to convert to moles before you can either convert to grams or to number of particles. Now there's a few things that we need to note here. So when we're looking at, let's say, the section that goes from moles to number of litres, we can see here that you need to take into account whether you are working with STP or whether you are working with RTP, and that is important, so you need to look out for that in the question. The second thing is, in a question, you may be actually asked, instead of litres, you could be asked to convert to centimetres cubed. Now, if you're asked to convert to centimetres cubed, we know up here on the top of the screen that there is 1,000 centimetres cubed in 1 litre. So that would simply mean, instead of multiplying by 22.4, you would multiply by 22,400 if it's STP, and if it's RTP, you would multiply by 24,000. Similarly, if we wanted to convert back from centimetres cubed to moles, again, that would be dividing by 22,400 or dividing by 24,000, depending on whether it is STP or RTP that you are dealing with. So that is one thing to look out for here in this flowchart. This one represents litres, but you could also be asked centimetres cubed. But that is just an application of knowledge, understanding that there is 1,000 centimetres cubed in a litre. So if you learn one of the ways, you should be able to do the other depending on the unit. Next, we'll look at a conversion from moles to grams. And if you're looking at moles to grams, you are simply going to be multiplying or dividing by the molecular mass. And what is key is you must always show your MR calculation when you are completing questions like this. Okay, you must show it. If you don't, there is potential that you could lose marks, and that is how they separate out H1 and H2 students from each other, with showing your calculations fully and in completion. The last part then is going from moles to number of particles. Now, when we're going from moles to number of particles or vice versa, we use Avogadro's constant, which is 6 by 10 to the 23. Now, it is important that when we say number of particles can refer to atoms, it can refer to molecules, and it can refer to even electrons or protons. Now, what I will say to you is, if we are to look at these in an order, going from biggest to smallest, we would start with molecules. There is atoms within a molecule, And then within those atoms, you have electrons or protons. And that is key when you are doing these calculations, that if you're asked for the number of electrons, you simply would not just multiply by 6 to the power of 23. You would need to check, right, well, is it a molecule I have? If it is, how many atoms are in it, or how many electrons are in it? One final formula that is worth noting, and I'm going to pop it over here in a red box for you, is the formula that moles can also be found by doing the molarity of a substance multiplied by the volume and divide that by 1,000. And that is visited in First Principles and also in the mole chapter videos. Now, if you want more information on this, you can go to the ExamRevision website, where you will find a full explanatory video on this conversion chart with worked examples of each conversion. But for today, we're going to assume that you understand all of this knowledge so that we can move on to our exam questions. So the big question on everyone's lips is stoichiometry. How important is it? Where does it appear on the paper? So the very simple answer is that stoichiometry, it appears everywhere. No matter what calculation you are completing in Leaving Cert, higher level, you are always going to be dealing with stoichiometry in some shape or form. But if we're looking to be a little bit more specific, stoichiometry will always appear in question 4. Now, in question 4, we can remember that question 4 is that multiple choice question, and there's 11 parts, of which you must answer 8 of them correctly. And with question 4, you are usually going to be looking at percentage composition, or you are going to be looking at empirical and molecular formula. The concept of stoichiometry is used in First Principles in titrations, and the titrations we know are in question 1, and the concept of it is used in the second part of our First Principles, where we take a look at the ratio of our standard solution to our unknown solution, and working out then the number of moles of our standard we have in comparison to our unknown solution. That involves the use of stoichiometry and balanced equations. And then another place it usually appears is in question 10 or question 11. And those, if it appears there, it's usually worth 25 marks. And in those situations, you will be given a balanced equation. And from that balanced equation, then you have to work out a series of calculations involving the balanced equation, involving the ratios, and again, involving the mole conversions that I just revised with you briefly there a few minutes ago. And finally, percentage and theoretical yield. It can appear in question 4 or also in question 10 and 11, but it does commonly come up at the end of question 2, which is your organic chemistry experiment question, where you're asked to find the percentage yield of whatever you are producing in question 2. But we're not going, as I've said already, we're not going to cover that in this video. We'll leave that for another day. So let's dig in, let's look at some exam questions and see where we can go. Let's take a look at this first exam question. So this first exam question is from 2018, question 10, part C. It says, when a rusty object was coated with phosphoric acid, all of the rust in the form of Fe2O3 on its surface was converted to iron phosphate according to the balanced equation. So first thing I will see from here is that I would say that the amount of FePO4, which is iron phosphate, is equal to the amount of rust removed. That's the first thing that we can take from that question. So the iron phosphate formed was found to have a mass of 4.53 grams. So that means the amount of rust removed was 4.53 grams. And we can use this information now to figure out the rest of the parts of the question. So let's begin. Let's start with part 1. So part 1 asks us about how many moles of iron were removed from the object in the rust treatment. And as I've said already, the amount of rust removed is equal to the amount of the iron phosphate that is formed. So I can see that there's FePO4, we have 4.53 grams of that. So if I convert that to moles, that will tell me how many moles of rust is removed in this part of the question. So we want to find the molecular mass of FeSPO4. So we know that the molecular mass of iron is 56 grams. We know that phosphorus has a molecular mass of 31 grams, and then I know that O4, which is 4 oxygens, will be 16 by 4. So that's 56, 31 and 64. And when I add those together, I get a molecular mass of 151. So we know that number of moles is equal to grams over molecular mass. So I can say that the FePO4 is equal to your 4.53 grams all over 151, which is 0.03 moles. So that means I can say that the rust removed is 0.03 moles. And for marks here, there was 3 marks for getting 0.03 moles and 3 marks for figuring out your molecular mass. And you needed to show the calculation with your molecular mass in order to get your full marks. Right, so let's look at part 2 then. Part 2 asks me what mass of rust was adhering to the object before the treatment. So that's asking me how many grams of rust there is on our object. So what I can see is that we have FeO3, that's my rust, and I have the number of moles of FePO4 that is formed. So there's 0.03 moles of FePO4 formed, so that means there would be 0.015 moles of our FeO3, which is iron oxide, and that's because it is a 1:2 ratio. So the number of moles that I have here, which is 0.03, must be halved on the other side of the ratio. The next thing we need to do is we want to find how many grams there is of in our 0.015 moles. So to do that, I need to get the molecular mass of our Fe2O3, that should be, which is our iron oxide. So Fe2 is equal to 2 by 56, and that is 112. And O3 is equal to 16 by 3, which is 48. So if I do the 112 plus the 48, I get that the molecular mass of the iron oxide is 160. Now, we know to go from moles to grams, you have to multiply by the molecular mass. So I can do 0.015 and I can multiply that by 160. And that will give me 2.4 grams. And the marks in this, there was 6 marks for this part of the question. So there was 3 marks going for the final answer and 3 marks going for your molecular mass. The next part of the question asks us, what was the minimum volume in centimetres cubed of a 6 molar solution of phosphoric acid needed to remove all of the rust? So we want to know how much phosphoric acid is needed to remove all of the rust. So the rust is the iron oxide there, and our phosphoric acid is the H3PO4. Now straight away I can see that this is a 1:2 ratio. And I know that I have 0.015 moles of my iron 2 oxide, and I've gotten that from the last question here, or the last part of this question, apologies. And because it's a 1:2 ratio, I multiply this, the number of moles here by 2 to find out the number of moles of my phosphoric acid, so I get 0.03. Now to solve this question out, we need to use a formula, and the formula is moles equals volume by molarity over 1000. And the key part here that we knew to use this formula is because they told us the molarity of the phosphoric acid. So we can't just go and multiply by 22.4 because we don't know if it's STP in order to find the volume. So we have to use this formula. So the number of moles fill in is 0.03. The volume is what we're trying to find, so I'm going to label that X. The molarity is 6, and we divide that by 1000. So I know that 30 is equal to 6x, so x must be equal to 5. and that's 5 centimetres cubed because the question asks for your answer in centimetres cubed. So it's 5 centimetres cubed of 6 molar phosphoric acid is needed to remove all of the rust. And there is 3 marks going for your balanced equation here and 3 marks for your final answer. The formula is important here to remember. The last part of this question, which is part 4, asks us what volume of water with a density of 1 gram per centimetre cubed was produced in this reaction. So again, let's compare our iron oxide, or our rust, to our water. And what we can see is it's a 1:3 ratio. But I don't have 1 mole of my iron oxide, I only have 0.015 moles. But because it's a 1:3 ratio, I will have 3 times as much water. So that means I will have 0.045 moles of my water. Now, in order to find this, where they're asking for volume, but again, they don't tell you if it's STP or RTP. So we cannot just multiply the moles by 22.4 or by 24. We have to go an alternative route. So the fact they give us the density here, if we multiply by 18, which is the MR of water, that will tell me that I have 0.81 grams of water, and I know that the density of the water is 1 gram per centimetre cubed, so that would mean that it will be 0.81 centimetres cubed of water that we have present, and that's coming from 1 gram per centimetre cubed of water is the density. And in that question, you got 2 marks for your ratio and 2 marks for your final answer of 0.81 centimetres cubed. So let's have a look at another exam question now. So this exam question comes from the 2014 paper. It is question 11, part B. In this exam question, we're looking at ammonium dichromate that's heated and decomposes according to the equation. And they tell you that there is 12.6 grams of the sodium dichromate crystals present at the beginning. So let's see how we can solve this question. So part 1 of this question is asking us how many moles of our ammonium dichromate reacted. So we're given the grams and we want to go to the moles of ammonium dichromate. So that must mean that we have to divide by our molecular mass. So the first thing to do would be to get the molecular mass of your sodium dichromate, which is NH42Cr2O7. So if I go with my N, there's 2 of them because it's NH42, so that means there's 2 N's. So that will be 2 by 14, which is 28. Then there will be 8 H's because it's H4 by 2, so that will be 8 by 1, which is 8. Next thing, we have 2 chromiums because it's Cr2, so that will be 2 by 52, which is equal to 104. And then we will have 7 oxygens because it's O7, so that will be 7 multiplied by 16, which is 112. And when you add all those together, what you get is you get a molecular mass of 252. So to go from grams to moles, as we've said already, you'll divide your 12.6 by 252, and that will give you 0.05 moles. When it comes to marks in this question, there's 3 marks going for your molecular mass and 3 marks going for your final answer in moles. And again, in order to get the full marks for your molecular mass, you need to show your calculations fully. Let's look at part 2 now. It says what mass of chromium oxide was formed. So here we go straight to our balanced equation and we write down ammonium dichromate, Cr2O7, is to our chromium oxide, Cr2O3, and we can see that that is a 1:1 ratio. But from part 1 here, we don't have 1 mole of our ammonium dichromate. We only have 0.05 moles. So that means the maximum amount of moles that we can produce of our chromium oxide is 0.05 moles. But the question asks us for the mass of chromium oxide formed. So we have moles here and we want to go to grams. So that must mean that we multiply by the molecular mass. So we have to go and find the molecular mass of our chromium oxide. So that is, there's 2 chromiums there, which is 2 by 52. and that is equal to 104. And then there is 3 oxygens, so that is 3 by 16, which is 48. So when you add the 104 and your 48 together, you will get 152. So to go from moles to grams, you multiply by the molecular mass. So we do 0.05 and we multiply that by 152, and that will give me 7.6 grams of my chromium oxide. When it comes to marks here, there's 3 marks for getting your balanced equation, ratio correct, apologies, and 3 marks for your answer of 7.6 grams. Part 3 of this question asks you what volume at STP of nitrogen gas is evolved. So again, we'll start off with our ammonium dichromate and we'll compare it to nitrogen gas. So again, we can see that it is a 1:1 ratio, but I don't have 1 mole of my ammonium dichromate, I only have 0.05. So that means I will have 0.05 moles of nitrogen gas produced. Now, because it says at STP, we can use our knowledge from our moles flowchart that we've previously covered. So I know to go from moles to litres that I multiply by 22.4 when it is at STP. And this is at STP because the question says so. So all I need to do is I need to do my 0.05 and I need to multiply it by 22.4. And that will give me 1.12 litres of nitrogen gas. And there is 3 marks going here for your ratio and 3 marks again for your final answer. So the last part of this question then is part 4, and it asks you the number of molecules of water produced. So here we are comparing our ammonium dichromate to our water. And I can see it's 4H2O. So this is now a 1:4 ratio. I don't have 1 mole of my ammonium dichromate, I only have 0.05, but I know I have 4 times as much water, so that means I have 0.2 moles of my water. Now, in order to find out the number of molecules that's present of something, or to go from moles to number of molecules, what you do is you multiply by 6 by 10 to the power of 23, which is Avogadro's constant that we would have met in the mole chapter also. So we do 0.2 multiplied by 6 by 10 to the power of 23, and that is 1.2 by 10 to the power of 23. But that is only the number of molecules of water that you produce. You are asked how many atoms of the water did you produce. And I can tell you that for H2O consists of 3 atoms. So that means each of these 1.2 by 10 to the 23 molecules consists of 3 atoms. So you must multiply that by 3. And you get 3.6 by 10 to the power of 23. And when it comes to the marks for this question, this was an all or nothing. You either got the final answer of 3 or you got 0. The final exam question that we want to look at today is actually the exam question from the most recent chemistry paper, which is 2023. It's question 10, part B. So in this question, we are looking at sunic acid and its salts that are used as food additives. The formula of the molecule of sunic acid is given here to us, and it tells us that the letter for N must be greater than 1. So very important to see here, reading the question carefully, we can see that there's an N value. So I would predict at some point during this question I'm going to have to figure out the value of this N. It then says that succinic acid reacts with sodium hydroxide according to the balanced equation, and this is it. So here we see a balanced equation, so straight away once I see that in a stoichiometry question, I know I'm going to be working with ratios. We're then told that 1 gram of the sunic acid reacts completely with sodium hydroxide and produces 2.43 grams of the disodium sunicate. And straight away then I can see, right, I've got grams here, so I may have to undergo conversion from grams to moles. So if we take a look at the questions, it says part 1, write expressions in terms of N for the molar masses of the sunic acid and the disodium succinate. So what I would say to you here is molar masses, they are simply referring to there is molecular mass. Then in part 2, we're going to have to write expressions in terms of N for the number of moles of succinic acid in 1.77 grams of the acid and the number of moles of disodium succinate in 2.43 grams of the salt. So here, straight away in part 2, I can see that they're asking me to convert from grams to moles. So we will be well able to do that based off the content of this video so far. Part 3 then asks you to find the value of N, the mass of 1 mole of succinic acid. So we're going to have to manipulate the content that we have from parts 1 and part 2 here to try and figure out part 3. That's the key thing with these questions. Usually you have to use answers from previous parts to move forward. And then the last part we can see here is a conversion. So they're asking me what volume of sodium hydroxide is required to complete the reaction containing 1.7 grams of succinic acid. So here I know, okay, I'm going to have to use my ratio, and I'm also looking to find volume, and I have molarity. So there's going to be a certain formula that we're going to have to use there. So let's dig in. So let's begin and take a look at part 1 of this question. So in part 1, they ask us simply to write expressions in terms of N for the molar masses of our reactant and product, which is succinic acid and disodium succinate. So what I would say here is when they're looking for molar masses, they are simply looking for the molecular mass. Now we know to find the molecular mass of anything, you add up the atomic masses. So let's do that for each of our molecules that we have. So let's look at the succinic acid first. So we can see here that we have our CH2. So that would be 12 plus 2 multiplied by N plus our 12 plus 16 plus 16 plus 1 times 2. So there's all my atomic masses. And when I do that out, I get 14 times N plus 45 times 2, which gives me a final answer of 14N plus 90. So that is my expression for the molar mass of the succinic acid. So let's look now at the disodium succinate, which is our product. We're going to take the same process here. We've got 12 plus 2, that's times N, plus 12 plus 16 plus 16. Now it's plus 23 this time because it's sodium, and we multiply that by 2. So that's going to give me 14N plus 72 times 2. So my molar expression for my disodium succinate is 14N plus 134. So that is the answer to part 1. So let's move on to part 2. Part 2 asks us to write an expression in terms of N for the number of moles of succinic acid and the number of moles of sodium dichromate. And we're given the grams of them. So if we're given the grams and we want to find the moles, and it says using the in terms of N, that means we're going to be using our molar masses that we figured out in part 1. And we know if we're using the molar masses from part 1, we must be doing grams divided by molecular mass. So let's do this now for our succinic acid and our disodium succinate. So for our succinic acid, we're told we have 1.77 grams of it. And I know that the molar mass of it in terms of N is 14N plus 90. And then so that is my expression in terms of N for the number of moles. I can't divide that because I don't know my value for N, so that is an expression. So now we go and get an expression for disodium succinate, which is, we're told we've 2.43 grams of that, and I know that the molecular mass of that is 14N plus 134. So that is my second expression that I need to complete part 2. So if we move on to part 3 then of this calculation, part 3 asks us to find the value of N, and then it asks us to find the mass of 1 mole of succinic acid. So if we're asked to find the value of N, I'm definitely going to have to use the two expressions that I've just created. And what I can do is I can let these two expressions be equal to each other. And the reason I can do that is in the question it says 1.77 grams of succinic acid reacts completely with sodium hydroxide to produce the 2.43 grams of the sodium succinate. So that means that the all of the succinic acid will react to produce the sodium succinate. So that means there should be no loss of mass. We know that from a junior cycle. So we can let them equal to each other. Now, when you let two expressions equal to each other, the simplest way to figure them out is to cross multiply. So that will give me 1.77 times 14n plus 134, and let that equal to 2.43 times 14n plus 90. Now we need to show the full workings of this, so I'm just going to do it out. Now, when we multiply this out, we have to get our letters on one side and our numbers on the other. So I'm going to bring my n's over to the right-hand side so I can keep them positive, and the numbers to the left. So what that will give me is it will give me 237.18 minus the 218.7, just from bringing it over. And then 34.02n, I'm going to take away 24.78n from that. And the reason I've just done that on those sides like that is to keep them positive. Usually I would bring the letters to the left and the numbers to the right, but it makes more sense to do it the other way around in this question so that I'm not dealing with minuses. So what I end up with is 9.24n is equal to 18.48. And if you divide that into the calculator, you will get that n is equal to 2. So that's the first part of part 3 done, finding the value of n. Now I need to go and find the mass of 1 mole of succinic acid. Now we know that 1 mole of anything is its molecular mass. So I want to find the molecular mass of the succinic acid, which is the CH2. Now I know that the N value is 2 by COOH2. And I know that because I figured out this is the formula for succinic acid in terms of N, and I know N is 2. So I suppose I might highlight those in a colour for you that you can see that's where the value of N is coming from, because I've just figured it out. So if you go and get the molecular mass of that, it's very simple. We can use our answer from part 1, which is 14N plus 90, and I can just fill in for N. So it's 14 times 2, because I know N is 2, plus 90. So what that gives me is 28 plus 90, which is equal to 118. Now, the long way you could do is you could go and you could do 12 plus 2 times 2 plus 12 by... So you could basically do this here with just the 2 in place. But I've just taken the final answer because it is much shorter. So I'm going to do part 4 now, and part 4 asks me what volume of 0.1 molar sodium hydroxide solution is required to complete this reaction containing 1.77 grams of succinic acid. So to me, straight away, I am definitely going to be working with my ratio here. So I am going to be looking at my succinic acid, which now I know is CH2 2 by COOH2, and I'm going to be comparing that to my 2NaOH, and I've gotten that from the balanced equation. Now I know that this is a 1:2 ratio, but I don't have 1 mole of my succinic acid. I'm told I have 1.77 grams, so I can figure out the number of moles of succinic acid there is by doing my 1.77 grams and dividing it by the 118. So I'm going to highlight these in red where I've gotten these from. So I know that I have 1.77 grams of succinic acid up there, and I know that the molecular mass of it is 118. I've just figured it out. So if I do grams divided by molecular mass, that will give me the number of moles of succinic acid I'm working with, and that is 0.015 moles. Now, if I come back to my ratio, it's a 1:2 ratio, but I don't have 1 mole of my succinic acid. I have 0.015. So if we're working on the ratio, that would mean that would produce 0.03 moles of my sodium hydroxide. Now, I'm not done at this point because the question doesn't ask me for the number of moles of sodium hydroxide produced. It asks me what volume, okay? So I need to now convert from moles to volume. Now, I'm not given I'm not told in the question if it's standard temperature and pressure or room temperature and pressure. So that must mean I cannot use the times 22.4 or the times 24 to figure that out. So what I need to do now is I need to use that formula that was in the red box at the start of this video. So there's the formula there in red. So the formula is moles equals molarity by volume times 1,000. Now I know the number of moles I have is 0.03 moles of my sodium hydroxide, and I know the molarity of it is 0.12. I don't know the volume, that's what I'm trying to figure out, and I can divide that by 1,000. So what that's going to give me is 0.03 over 0.12 times that by 1,000, just by rearranging to get V on its own, and I will get that my volume is 250 centimeters cubed. And at that point now, I have completed this question. So the last thing we want to do in this video is we want to assign the marks. So if we look, I will do the marks in green so that they stand out for you. We would have gotten 6 marks for part A, so that was 6 marks for part 1, 3 marks for your first formula and 3 marks for your second. Same for part 2 then, 3 marks for your each expression that you had. Now, when it came to part 3, the marks were separated based on the steps that were shown. So you got a total of 4 marks for showing your work and finding the n value. So you got 2 marks for finding the n value, and then you got 2 marks for one of the steps in the green part that I've just marked there. So you needed at least one of these to pick up your other 2 marks. So that shows you the importance of doing workings and showing workings fully in calculation questions. And then the last set of marks in this part was for the number of grams, finding the molecular mass, and they gave you 3 marks. Then when it comes to part 4, you were given 2 marks for figuring out the number of moles of your succinic acid that you had. Then you were given 2 marks for figuring out the number of moles of your sodium hydroxide, and finally 2 marks for filling into the formula and finding the volume. So that's it for today's Saturday session video. Thanks a million for joining in. We looked at stoichiometry, we summarised some of the key parts of it, and we looked at some exam questions. If you want some more exam revision content in the area of Leaving Cert Chemistry, go to examrevision.ie, and there you will find the full Leaving Cert course completed with H1 standard notes, videos to go along with it, worked solutions to exam questions, and self-correcting quizzes. And follow us on our social medias. We're on Twitter, Instagram, TikTok, Facebook, and of course YouTube, where you will find all of the latest Saturday sessions, information on upcoming revision courses, and access to our website. So hopefully I'll see you at the next Leaving Cert Chemistry Saturday session, which is coming soon. Keep an eye on the socials for more updates. Bye guys.